Okay, here's an interesting one. In 3-axis, we provided the ability to use both surfaces and curved regions. And when you do that, you can, similar to the way, in 2-axis operations where you have a nesting perimeter, you have an outer perimeter and an inner perimeter, and then the toolpath is actually between the two. And if you look at the picture over here, we're selecting one part surface in the part surfaces tab, and this is parallel finishing, 3-axis. And then over on the containment regions tab, we've added these curves, as you can see in orange here, that go around the base of this feature. So the result then is parallel finishing will only take place between those two areas to the perimeter of the surface, and then stops at the inner curve region. So this is something that if you have some complex features in 3-axis that you need to cut, this will come into play and help you out. A little bit more control in the 3-axis parallel finishing. And it's not, correct me if I'm wrong, Joe, I don't think it's just in the parallel finishing. Is that the case? It might be another. Well.
It's in all 3-axis. It's on all 3-axis methods.
Okay, good. So, and again, I wanted to mention, if you guys got any questions, please add them into the questions tab in your dialogue, and we'll be looking at them in the background and we'll get them answered for you. Okay, so what we have here is 3-axis milling enhancements. So it's 3-axis drive curves and surfaces combination of geometry. So previously, in previous versions, you either did surfaces or you did curves. Okay, so if you was doing curves and you wanted to get the same outcome, you would have to select all of the curves around the edge of the surface, then all the curves around here, and it would figure that out and cut between them. So now it just makes it a lot easier if you're going to avoid features like this in 3-axis. Okay. Now in 3-axis operations, you can combine, for your control geometry, you can combine both surfaces and curves, okay? And they act in a nesting type relationship. So in this particular example, we have a surface, okay? This is our base surface, okay? And then we have a feature on top of that surface that begins, it rolls up, off of that surface, okay? Now, to cut this, you may not want to cut this feature as part of the surface. You may want to just do the surface first, okay? So in cases like this, you can now select both the surfaces and the curves in order to get a nested effect. So let's look at the parallel finishing operation. So in this particular example, we have a part surface selected on the part surfaces tab, okay? So this is the green edges here. That's our surface, our base surface. And then for containment regions, we're selecting these perimeter curves, okay? All the way around the base of this feature. So what happens now when you generate that, the inner curves will serve as a void region. So the tool will not violate these inner curves. So I know you may be wondering, well, these curves are completely inside the surface. What happens if they don't? What happens if they fall off of the surface? Okay, so we'll get another example here. If you look at the top view, okay, look at the top view, and let's go into a wireframe for now. So we got the surface and we got a planar rectangle here, okay, that is partly on and partly off the surface. Let's take a look at what that looks like here. Let's turn the surfaces back on. Okay, let's go to, well, let's just take a look at it. As you can see, it just, creates an void region where that where the curve geometry intersects with the surface geometry, it treats that as an avoid region. Okay, so think of it as having an avoid regions in three axis, where prior versions avoid regions basically applied the two axis, but you could do it in three axis. Okay, if you selected the curves in a certain way, like edge curves of the surface and edge curves in here, it will figure out that some of these curves are inside the other curves, but it's more of a complex situation. You could run into possibly some conditions where it could be a problem. Okay, so now you can use both surfaces and curves together to generate your toolpath in three-axis methods. And a lot of these three-axis methods you will see that you can put both containment regions and part surfaces in the same operation. Okay,